Welcome, my beloved primary 4 students, in the 4th lesson of energy and collision concept. In today's lesson, we will finish our last activity of learn. Then, we will begin share activities. We will collect all the pieces of evidence that we have learned in the concept to write the scientific explanation for the question of can you explain? فاكرين السؤال كان إيه؟ What happens to objects when they collide with another object? We have learned in this concept that the energy transfers between objects during the collision. بيحصل انتقال الطاقة وقت التصادم. And the greater the speed and mass of a moving object, the greater the kinetic energy this object has. كل ما السرعة والكتلة زادت، كل ما الkinetic energy كمان هتزيد. During our last lesson, I asked you to think of when an object collides with another one. It transfers all its kinetic energy or just some amount of it. And does the energy disappear in a collision? To be able to answer that question, we will see together a practical example of energy transformation in Activity 9, Analyze like a scientist. In Analyze like a scientist, we are going to use a simple device called Newton cradle. Newton cradle. A lot of people like to buy this cradle because of its special way of moving. طيب، إيه special way of moving؟ بيتحرك إزاي يا ترى؟ Try to think about this. Why? When we pull the first ball, then we let it go. The last ball starts moving back and forth. تعالوا نشوف كده. Although the balls in the middle didn't move. ايه اللي بيحصل هنا؟ ليه لما سبت أول كورة آخر كورة اتحركت والكورة اللي في النص كانت تقريبا شبه ثابتة؟ Do the balls will keep moving or they will stop? When I asked that question to a student in my class called Muhammad, he said that the cradle will keep on moving and will not stop. قال كده ليه؟ Because the balls keep gaining energy from one another, so there is nothing going to stop them. But Hiba had a different opinion and said that they will stop at some point because the ball's speed will be slow due to the friction between the balls. Friction كانت قوة الاحتكاك. So their kinetic energy will be less over time till it disappears and they stop. So who do you think have the right answer? Muhammad or Hiba? I want you to write your opinion in your notebook. Then let's watch the video together to know who has the right answer. While you are watching, try to draw pictures describing the energy transformations from the cradle movement or the first moment of pulling back the first ball. عايزاكم تجربوا ترسموا اللي انتوا شايفينه في الفيديو. Okay? Let's watch the video.
Have you ever seen one of these? It's called a Newton's cradle. A row of 5 silver balls, usually made of steel, is suspended from a frame by thin wire. Sometimes adults like to have a Newton's cradle as a desk toy at work. Watch out, they can be mesmerizing. But what's going on here? When the outermost ball at one end is pulled back and released, the balls in the middle hardly move, but the outermost ball at the opposite end is pushed away from the frame. A Newton's cradle is a good demonstration of energy transfer. The ball that you pull has potential energy, which converts into kinetic energy when you let it go and causes it to collide with the next ball. The energy is then transferred down the line. It's only when the energy is transferred to the outermost ball at the opposite end that there is significant movement, because it doesn't have another ball to transfer its energy to. Now let's look. If you pull two of the balls, what's going to happen? Why do you think the energy here is able to move two balls at the other end?
خلصتوا رسوماتكم؟ تعالوا اوريكم انا هرسمها ازاي. في الكريدل we have 5 balls. أول حاجة احنا عملناها ايه؟ First we pull back the first ball. أول حاجة عملناها شدينا أول كرة لورا. We pull back the first ball. رجعناها لحد هنا. طب كان ايه بيحصل دلوقتي؟ We do work on it so it stores potential energy. أنا هنا برفعها عن الأرض فهي عمالة تخزن gravitational potential energy. And once we let it go, the energy converts from potential energy to kinetic energy. أول ما سيبنا الكرة إيه اللي حصل؟ الانرجي دي ابتدت تتحول لكايناتيك انرجي فابتدت الكرة دي ترجع تاني مكانها. لما رجعت مكانها حصل إيه؟ The ball transfers its kinetic energy to the second ball. Then the second ball keep transferring till it reaches the last ball. السكند بول نقلت الانرجي للثيرد والفورث لحد ما الانرجي وصلت عند اخر كوره. طب لما الانرجي وصلت لللاست بول it didn't find any object to hit. هنا مفيش حاجه تنقل لها الطاقه فهتعمل ايه بالكايناتيك انرجي اللي عندها؟ هتبتدي تتحرك. So its motion will be free. So this ball will start moving in this direction. وهيبقى مكانها هنا. Okay? So it will be free. Then the last ball rises up in the air and stores potential energy as it's going up. هتطلع بعيد عن الأرض فهتخزن gravitational potential energy. بعدين إيه اللي هيحصل؟ هتبتدي تنزل تاني وهي نازلة the gravitational potential energy converts into kinetic energy. الطاقة دي هتبتدي تتحول تاني ويحصل نفس السيكونس. الكايناتيك انرجي هتتنقل من الكورة دي لدي لدي لحد ما نوصل لآخر كورة. لما نوصل عند آخر كورة هتبقى free. So it will start rising up. تخزن potential energy وبعدين هتبتدي ترجع تاني. So the transfer from potential energy to kinetic energy is continuous. So why when we pulled back 2 balls in the video as you saw, they were able to move another 2 balls in the opposite direction to move. ايه ده؟ لما شفنا في الفيديو ان هو رفع 2 balls ايه اللي حصل؟ لقينا ان في الother side 2 balls كمان اتحركوا. Why not only 1 ball? That's what we will know when we read the text in page 231 and 232. I want you to get your pen. Try to focus while you are reading and highlight all the forms of energy to which kinetic energy is transformed. عايزاكم تعملوا highlight على كل أشكال الطاقة اللي هتتحول لها طاقة الحركة. When the balls colloid during collision. يا ترى اللي احنا قريناه ده بيحصل بس في نيوتنز كريدل ولا بيحصل كمان في حياتنا؟ طب تعالوا كده نتخيل موقف. Let's imagine a discussion we are going to have if I asked you what would happen if a moving car collided with a stop sign but not all the kinetic energy transfers to the sign. اوكي؟ تعالوا نتخيل موقف ان عربية ماشية هتخبط في stop sign بس مش كل طاقة الحركة هتروح للstop sign. Where do you think the rest of the car's kinetic energy goes? Think about what you are going to see, hear, or feel in the collision site. At the time of collision, you will hear a bang, which resulted from the sound energy, which is one form of kinetic energy. يبقى أول حاجة نسمعها صوت البانجينج. Also, the friction of the car with the sign will generate thermal energy, heat energy, in the form of heat, which you can easily feel if you touch the sign. And thermal energy is one form of kinetic energy. And that means that the car's kinetic energy didn't all disappear in the collision, but instead it transformed. الطاقة ما اختفتش لكن اتحولت into different forms of energy. That's the rule we got from the text, which is very important to understand the energy transformation that's happening in collision. من أهم الحاجات اللي قريناها في التكست هي تحولات الطاقة اللي بتحصل في الاصطدام. A great example of the rule of energy conversions is collision in Newton's cradle. The rule we get says that. تعالوا نكتب الرول ده عشان تركزوا عليه قوي. The amount of energy before the collision, the amount of energy before collision قبل التصادم equal هيساوي ايه يا ترى؟ equal the amount of energy generated after collision. Equal the amount of energy generated after collision. بمعنى إن الطاقة قبل التصادم قد الطاقة بعد التصادم. But what does this rule exactly mean? We know that any moving object has kinetic energy and its amount depends on the mass and the speed. أي جسم متحرك عنده طاقة حركة وهتعتمد على الماس بتاعته والسبيد بتاعته. When an object collides with another object, it transfers its kinetic energy to the one it collided with. That's why when the first ball in the cradle transfers its kinetic energy to the second one, then to the third one, and so on. When you pull back two balls, then you let them go, that means you have more kinetic energy in the first ball and the second ball. That's why when this amount of energy transfers through the middle ball, it makes two other balls in the opposite direction move. لما جينا في التكست قلنا ليه لما رفعنا كورتين في كورتين اتحركوا الناحية التانية؟ تعالوا نفكر ببساطة. أنا لما رفعت كورتين كده بقى عندي two kinetic energy of two balls, kinetic energy of ball 1 و ball 2. طبيعي لما هيخبطوا في الكورة اللي في النص هيتحرك هتنقل two kinetic energies يبقى عندي two balls on the other side will move برضه. The important question is, does the Newton cradle will keep on moving or will stop? That's the part I asked you to highlight in the text. وأظن إن معظمكم كمان عملتوا له highlight. ركزوا جدا على الجزء ده. It's like the car and the stop sign collision. Some amount of kinetic energy the ball have transforms into different forms of energy, like sound energy that you hear when the balls are colliding, or the generated heat from the friction between the balls, as well as the air resistance. كانت إيه ال air resistance دي؟ كانت الفريكشن between the objects that are moving in air. يعني لو أنا بجري في الهواء بحس إن الهواء بيخبطني. هو ده ال air resistance، ده نوع من أنواع الفريكشن فورس بيحصل للأجسام اللي بتتحرك في الهواء. While you were studying the speed concept, you learned about the friction and its types. ما تنسوش ده. عايزين نركز تاني على الرول. احنا اتفقنا ان amount of energy قبل الكوليجن قد ال amount of energy after collision. طب الانرجي اللي after collision دي هتظهر في صورة ايه؟ 3 حاجات. kinetic energy، كمان sound energy و heat energy resulting from friction. اوكي. تعالوا نكمل كلامنا. بعد ما حكينا الحركة بتاعت نيوتنز كريدل، عايزاكم تفكروا بيحصل ايه في الآخر. At the end, as the kinetic energy continues its transfer between the balls, while it transforms into different forms of energy, the cradle reaches a point, then it stops moving. So it will stop moving because the ball loses all their kinetic energy. But does this mean إن كده الانرجي disappeared؟ لا, this doesn't mean that energy disappeared or lost. Because we agreed before, energy doesn't get destroyed. احنا اتفقنا ان الانرجي مش هتتحطم ولا هتختفي. So راحت فين الطاقة دي يا ترى؟ قلنا ان kinetic energy هتتحول لsound و heat energy. So even when the balls are not moving, they still have a stored energy inside them, which is ready to do work if I get affected by the force. Like when you pull back the ball making the cradle to move once again. البولز حتى وهي ما بتتحركش كده جواها طاقة. طاقة إيه؟ طاقة الوضع potential energy، وهي جاهزة إنها تعمل شغل، جاهزة إنها to do work. So if I move any one of the balls الكريدل هيبتدي حركته تاني. I think that at the end of this activity we will have all the pieces of evidence we might need to go back one more time to the investigative phenomena and answer the main question. What happens when a bat hits a ball? فاكرين الكريكت bat? This will be the last activity in our lesson. Activity number 10, record evidence like a scientist. I want you to open your book on page 233 to the investigative phenomena and start thinking about how can you describe what's happening when the cricket bat hits the ball. And after all the pieces of evidence we collected during the concept, now it's much easier for you to explain. I think your explanation will differ from your first written explanation on page 215. This time, I'll help you to organize your ideas before you start to answer. So I'll tell you a group of key vocabulary that you can use some or all of them in your explanation. هساعدكم شوية دلوقتي. Get your pen واكتبوا الكلمات اللي هقولها لكم. تقدروا تستخدموها كلها في شرحكم أو جزء منها. أول كلمة potential energy. Second, kinetic energy. Speed, distance, force, equals, mass, lose, sound, energy, thermal energy. Now you can start recording your answers, and when we get back, I'll tell you about the answers my students wrote using these key vocabulary. محمد said using 6 words from what I wrote before. أنا اتفقت معاك وتقدروا تستخدموهم كلهم أو جزء منهم. The cricket bat has potential energy while it's in the player's hand because he holds it high above the ground. يبقى كده عندها إيه؟ عندها gravitational potential energy. Then it transforms into kinetic energy when the player moves the bat back and forth. When the player hit the ball by his bat, the kinetic energy transfer from the bat to the ball, leading it to change its direction and speed. لما الكورة هتخبط في المضرب، الكورة هتغير اتجاهها وسرعتها. The ball will travel forward to a large distance if its kinetic energy increases. طب هبة كتبت إيه؟ هبة wrote the ball speed depends on the force of the strike of the player. سرعة الكورة هتختلف على حسب قوة اللاعب. The bat's kinetic energy equal the kinetic energy resulting in the collision. إذا أنت استخدمتي الرول هايل. The bat loses some of its kinetic energy during collision with the ball, and this energy appear in the form of sound and heat energy. Of course, you notice that Muhammad uses in his explanation the evidence we tested ourselves in the investigation about the relation between speed and kinetic energy. Like how each time the kinetic energy increases, the distance the object travel also increases. فاكرين لما عملنا incline والعربية كانت بتنزل وتخبط الكوباية؟ كان كل ما السبيد بتزيد كل ما كانت الديستنس بتبقى أكتر. That's what was different from his first explanation he wrote. Hiba said that the difference in her explanation is that she added some points from what we learned today. The first point is the amount of kinetic energy before collision equal the amount generated after the collision. زي ما كتبنا الرول على البورد ما تنسوهاش. The second point Hiba added is about the different forms of kinetic energy transformations that are produced during collision. هي اتكلمت على الساوند والهيت. لو انتوا فاكرين ان الطاقة اللي بتطلع بتتحول لساوند وهيت energy. She also used the force term as she remembers the investigation in which we made different trials about the amount of energy that affects the clay. فاكرين لما اصحابنا كانوا هنا وجابوا الكلي وحدفوه بديفرنت فورسز وشفتوا الايفكت على الكلي كان عامل ازاي؟ هي استخدمت كلمة force. Let's write the scientific explanation of the question of can you explain, which always starts with claim, evidence, reasoning, of course. I think now you know that you can write the claim as an answer to the question of can you explain or any other question you were thinking about at the beginning of the concept. طب بنكتب الكليم ازاي؟ To write a claim in energy and collision concept easily, you can think of questions related to different collision situations in which you can change factors like speed, mass, energy, and motion. عايزاكم تفكروا دايما في مواقف حواليكم لأن كل اللي بندرسه مرتبط باللي بيحصل حوالينا. For example, what will happen if a truck and a car moving with the same speed but they have different masses؟ طبيعي إن التراك عندها bigger mass and they collided with a wall. A person riding a bicycle collides with a moving car from behind. في شخص سايق البايسكل وفي عربية جت خبطته من ورا. إيه اللي هيحصل؟ What will happen if a train collides with a train moving with the same speed but in opposite direction؟ كل دي أسئلة تقدروا تجاوبوا عنها. Your answers to these questions will make it easier to you making the claim, and so you can collect different pieces of evidence from the activities we did that prove that your claims are true. الevidences بتاعتنا هتبقى من activities اللي عملناها. I'll give you some time to think quickly of the claim and the evidence that can prove it. Then we will come back to share with you a claim from the questions I suggested. أظن إن كلكم كتبتوا الكليم بتاعكم وأنا كمان كتبت الكليم، بس أنا عملته على شكل حدوتة صغننة كده. تعالوا نسمعها. If two trucks running at 120 km per hour and 60 km per hour collides with a concrete wall، خبطوا في concrete wall. The people will hear a higher sound of the first truck and its front will be damaged. One of the pieces of evidence we can collect very easily to prove that claim is true is an evidence from the text in activity number 5, the effect of speed on collisions. The faster an object travels, the more energy it has. Some of this energy will be in the form of heat, light, or sound. أنا كمان كان عندي evidence تاني. My evidence was from the text activity number 7, the effect of mass on collisions, which is the bigger the mass of the vehicle, the more fuel it consumes and the more kinetic energy it gains. يعني لو أنا قصادي two cars with different masses, okay? The heavier car هتستخدم more gasoline to move، عشان كده هيبقى عندها more kinetic energy وهتعمل more damage, okay? So this one with the bigger mass, more kinetic energy. اتفقنا؟ This one with a small mass, so it has small kinetic energy. طيب, now we are talking about the mass of the truck, which means its mass is big, of course. The result we conclude from the investigation, activity number 8, about the relation between the speed and kinetic energy, and when the mass of the two objects is equal. طب لو الكيس كده ما كانتش زي دي، كان عندي عربيتين نفس الماس، كان ايه اللي هيحصل؟ تعالوا كده نفكر. If I have two objects with equal masses, the faster the object will have, the more kinetic energy. لو عندي two masses يبقى وقتها انا مش هبص للماس خالص، الاثنين equal mass يبقى مش هبص للماس، هبص لمين؟ للسبيد. The faster car, the more kinetic energy it has. Okay? So, after we collected enough pieces of evidence, we can write the reasoning that supports our pieces of evidence. بعد خلاص ما كتبت الevidence بتاعتي، تعالوا نقول الreasoning. And we need to make sure that these reasoning are true. So we should start explaining them and say how they are related to the claim we wrote and support the reasoning. Although the mass of the two objects is equal, but the first truck is faster. احنا كنا قايلين ان اول عربية 120 km per hour. So this car is faster than the second one. So it has more kinetic energy during collision. The kinetic energy of the two trucks is transferred to the concrete wall. And because of the large mass of the wall and the speed of the first truck, its front is destroyed. But the damage is smaller in case of the second truck. لأن هي أبطأ فعندها less kinetic energy يبقى هيحصل less damage. Because of the speed difference. Different forms of kinetic energy transformation are produced زي إيه مثلا؟ زي sound energy. هتبقى greater in which case? It's greater in the case of the faster truck because its kinetic energy is greater than the second truck. The scientific explanation of the claim I wrote clarifies differs factors I mentioned that affect collision. زي إيه؟ زي speed, mass, kinetic energy, and shows that the amount of energy moving object depends on its mass and its speed. An object that moves fast has more energy than an object of the same mass that's moving slowly. زي ما قلنا في العربيتين، مين هيبقى عنده more kinetic energy؟ الكار اللي بتتحرك بالسرعة، لأن هما الاتنين عندهم نفس الماس. That's why it will do more damage. When objects colloid, their kinetic energy is transferred into different forms like heat and sound energy. You can continue and think in different claims that help you write scientific explanation to the question, can you explain? And if you have any question, you can write them in the comments on مدرستنا Facebook page. So this is the end of our lesson. We recorded a final explanation of can you explain question. And we also knew that what happens to objects when they colloid with one another, and the main transformation of energy and the different factors that affect the severity of collision. Severity of collision يعني قوة التصادم. زي إيه الفاكتورز دي؟ speed السرعة، mass heavy or light, and their kinetic energy طاقة الحركة اللي عندهم. Your last task is very easy and interesting, and you will do it with your colleagues in the class. You will collect the different terms, key vocabularies, and concepts which we learned in the concept lessons and write them in a small paper and fold them, then put them in a box. عايزاكم تجمعوا كل الكلمات الجديدة اللي انتوا درستوها في الكونسبتس بتاعتكم وتكتبوها في ورق وتقفلوا الورق وتحطوه في box. Each one of you will choose a paper, then see the term in it. هنطلع ورقة ونقرا الترم اللي فيها. And try to tell your colleagues about it. بس خلي بالكم مش هتقولوها كلام. You should describe it by acting or making demonstration. طب زي إيه مثلا؟ For example, I'll start now. This is what. When I do this, it's pushing force. طب what about this? Excellent, collision. You can continue the game with your colleagues. Till we meet in our next lesson, I need you to collect all your information about this concept to share in solving a group of puzzles with the crash investigators. So, what information do you think you need and how the investigation of car crashes is done? We will know that in our next lesson. Thank you and see you next time.